Module 4, 3D Computer Animation. Overview of 3D Computer Animation. 3D computer animation is a form of animation that uses digital technology to create three-dimensional characters, objects, and environments in a virtual space. It involves the use of computer software to model, rig, animate, and render 3D objects, resulting in realistic or stylized animations that can be used in various mediums, such as films, video games, commercials, and more. Here's an overview of the main steps involved in creating 3D computer animation. 1. Modeling. Modeling is the process of creating 3D objects or characters using computer software. Artists create digital 3D models by manipulating vertices, edges, and faces to create a mesh that defines the shape and form of the object or character. Modeling can range from simple geometric shapes to complex and detailed models with textures, materials, and lighting properties. 2. Rigging. Rigging is the process of adding a virtual skeleton, known as a rig, to a 3D model. The rig allows animators to control the movement and deformation of the model, such as bending limbs, rotating joints, and squashing and stretching body parts. Rigging also involves setting up controls, such as sliders, buttons, or other user interfaces, to make it easier for animators to manipulate the rig and create animations. 3. Animation. Animation is the process of bringing 3D models to life by creating movement and performances. Animators use the rig to pose and animate the models, setting keyframes for different poses or positions at different points in time. They also adjust timing, spacing, and other animation principles to create realistic or stylized motion. Animation can include various types of movements, such as character performances, object interactions, camera movements, and more. 4. Lighting and materials. Lighting and materials are important aspects of 3D computer animation that contribute to the visual appearance and atmosphere of the scene. Lighting involves setting up virtual lights in the 3D scene to simulate realistic or stylized lighting conditions, such as sunlight, moonlight, or artificial lighting. Materials involve defining the appearance and properties of surfaces, such as textures, colors, reflectivity, transparency, and more, to make the 3D models look more realistic or stylized. 5. Rendering. Rendering is the process of generating the final images or frames from the 3D scene. It involves using computer algorithms to calculate the interactions of light with the virtual objects, materials, and lights in the scene, and producing the final images or frames with all the lighting, shading, and materials applied. Rendering can be time-consuming and resource-intensive, as it requires a lot of computational power to produce high-quality images or frames. 6. Post-production. Post-production involves the final steps of editing, compositing, and adding other visual and audio effects to the rendered frames to create the final animation. This may include editing the timing, adding sound effects, music, voiceovers, and other post-processing techniques to enhance the overall look and feel of the animation. 3D computer animation offers a wide range of creative possibilities and is widely used in various industries, including entertainment, advertising, education, architecture, and more. It requires a solid understanding of 3D modeling, rigging, animation principles, lighting, and rendering techniques, as well as proficiency in specialized 3D animation software, such as Maya, 3ds Max, Blender, and others. Creating 3D models and characters. Creating 3D models and characters is a crucial step in 3D computer animation. It involves using specialized software to create three-dimensional digital objects or characters that can be animated and rendered. Here's an overview of the main steps involved in creating 3D models and characters. 1. Conceptualization. Before creating 3D models, it's important to have a clear concept or design in mind. This may involve sketching, storyboarding, or creating concept art to visualize the desired look and feel of the object or character. 2. Modeling. Modeling is the process of creating the 3D geometry of the object or character using specialized modeling tools in 3D software. Artists manipulate vertices, edges, and faces to create a mesh that defines the shape and form of the object or character. Modeling can range from simple geometric shapes to complex and detailed models with intricate details. 3. Texturing. Texturing involves applying textures or images onto the 3D model surface to create its visual appearance. Textures can include colors, patterns, images, and other visual elements that add realism or stylization to the model. Artists can either create their own textures or use pre-made textures from libraries or online resources. 4. Rigging. Rigging is the process of adding a virtual skeleton, known as a rig, to a 3D character model. The rig allows animators to control the movement and deformation of the character, such as bending limbs, rotating joints, and squashing and stretching body parts. Rigging also involves setting up controls, such as rigging handles or controllers, to make it easier for animators to manipulate the character for animation. 5. Animation. Animation is the process of bringing the 3D character to life by creating movement and performances. Animators use the rig to pose and animate the character, setting keyframes for different poses or positions at different points in time. They also adjust timing, spacing, and other animation principles to create realistic or stylized motion, bringing the character to life. 6. Rendering. Rendering is the process of generating the final images or frames from the 3D scene, including the models and characters. It involves using computer algorithms to calculate the interactions of light with the virtual objects, materials, and lights in the scene, and producing the final images or frames with all the lighting, shading, and materials applied. Rendering can be time-consuming and resource-intensive, as it requires a lot of computational power to produce high-quality images or frames. Creating 3D models and characters requires artistic skills, technical knowledge of 3D modeling software, and a solid understanding of anatomy, proportions, and aesthetics. It also involves creativity and attention to detail to bring characters and objects to life in a believable and visually appealing way. Using rigging and animation tools. Rigging and animation tools are essential components of 3D computer animation that allow animators to create realistic movement and performances for characters or objects. Here's an overview of how rigging and animation tools are used in the animation pipeline. 1. Rigging. Rigging involves creating a virtual skeleton, also known as a rig, for the 3D character or object. Rigging tools provide controls and parameters that allow animators to manipulate the rig to create movement. The rig typically consists of joints, also called bones, which are interconnected in a hierarchy to mimic the movement of a real skeleton. These joints are then bound to the character's geometry to enable deformation when the rig is manipulated. 2. Rigging controls. Rigging controls are user-friendly interfaces that animators use to manipulate the rig. These controls can include handles, sliders, and buttons that allow animators to control the position, rotation, and scale of the rig's joints. Advanced rigging setups may also include custom scripts or expressions that automate certain movements or behaviors of the character. 3. Animation. Once the rig is set up, animators can start animating the character or object. Animation tools provide a range of features that allow animators to create performances by setting keyframes, manipulating poses, and adjusting timing and spacing. Keyframes define the starting and ending poses of an animation, and animators set them at specific points in time to create motion. Animation tools also provide interpolation techniques, such as linear or spline interpolation, to create smooth transitions between keyframes. 4. Animation layers. Animation layers are features in some animation tools that allow animators to create multiple layers of animation on top of each other. This enables animators to animate different parts of a character or object independently, such as the body, facial expressions, and props. Animation layers provide greater flexibility and control in creating complex animations with multiple components. 5. Physics and simulation. Some animation tools also provide physics and simulation features that allow animators to create realistic physics-based animations, such as cloth simulation, hair simulation, or physics-based interactions between objects. These tools use algorithms to simulate real-world physics, such as gravity, collision detection, and rigid body dynamics, to create realistic motion and interactions in the animation. 6. Iterative refinement. Animation is an iterative process that involves refining the animation over time. Animators may review and revise their work multiple times to ensure that the movement is natural, appealing, and conveys the desired performance. Animation tools provide features such as timeline scrubbing, play blasting, and rendering previews that allow animators to review and fine-tune their animation as they progress. Rigging and animation tools are critical for creating believable and visually appealing 3D character animations. They require a combination of artistic skills, technical knowledge of the animation software, and a keen eye for movement and performance. With the right tools and techniques, animators can create compelling animations that bring characters and objects to life on screen. Applying timing and spacing to create effective animation. Timing and spacing are fundamental principles of animation that are used to create effective and believable motion. They play a crucial role in the overall quality and impact of an animation, whether it's hand-drawn, stop-motion, or 3D computer animation. Here's an overview of how timing and spacing are applied in animation. 1. Timing. Timing refers to the speed or tempo of an animation. It determines how fast or slow an object or character moves, and how long it takes to complete an action. Different timing can convey different emotions, moods, and energies in an animation. For example, fast timing can create a sense of urgency or excitement, while slow timing can convey weight, tension, or relaxation. Timing is controlled by setting the keyframes at specific points in time on the animation timeline. Animators determine the appropriate timing for each action or movement based on the desired effect and the character's or object's characteristics. They consider factors such as the character's size, weight, age, and personality, as well as the style and tone of the animation. 2. Spacing. Spacing refers to the distribution of positions of an object or character between keyframes. It determines the trajectory and flow of the movement, as well as the smoothness and naturalness of the animation. Proper spacing is essential to create realistic and appealing motion. Animators adjust the spacing by manipulating the position and interpolation of keyframes. They pay attention to the arcs, trajectories, and overlaps of the movement to ensure that it looks natural and follows the laws of physics. They also consider the character's or object's anatomy, weight, and balance to create convincing motion. 3. Ease in and ease out. Ease in and ease out are techniques used in animation to control the acceleration and deceleration of motion. Ease in refers to the gradual acceleration of an object or character at the beginning of an action, while ease out refers to the gradual deceleration at the end of an action. Ease in and ease out are important for creating smooth and natural motion that mimics the physical world. Ease in and ease out are achieved by adjusting the timing and spacing of keyframes. Animators typically use more keyframes at the beginning and end of an action to create the ease in and ease out effect. This technique adds subtlety and realism to the animation, making it more visually appealing and convincing. 4. Staging and posing. Staging and posing are also important aspects of timing and spacing in animation. They involve setting up the right poses and positions for the characters or objects to effectively convey the intended action, emotion, or story. Proper staging and posing can enhance the clarity, impact, and storytelling of an animation. Animators carefully choose the poses and positions of the characters or objects in each keyframe to create dynamic and expressive poses that support the story and the mood of the animation. They consider factors such as composition, silhouette, balance, and facial expressions to create visually appealing and communicative poses. In summary, timing and spacing are crucial principles of animation that are used to create effective and believable motion. They are controlled by setting the keyframes, adjusting the spacing, and applying ease-in and ease-out techniques. Proper staging and posing also play a vital role in creating visually appealing and communicative animations. Mastery of timing and spacing is essential for animators to create animations that captivate audiences and tell compelling stories.
Thanks for watching. For more information, like, comment, and subscribe our channel.